Okay, so for this question, it's asking us to solve, it's called solve an initial value problem. And if you've watched any of the other videos or looked in the textbook about finding antiderivatives, what you probably have seen, and I'll just go over that briefly here. So I get these functions: x squared plus 2, x squared minus 4, x squared plus 0, x squared minus 9/5. If I take the derivative of each of these functions, right, if I do d dx for each of these, I'm going to get 2x. Don't they all have the exact same derivative? So then if I'm trying to find the antiderivative, remember we're going to use that power rule for antiderivative. So I'm going to add one, instead of taking away one, I'm going to add one for these power functions. And then I divide by that new exponent. So 2. So 2x squared divided by 2 is just x squared. So you see how all of these have a leading term of x squared. But do we know, is it x squared plus 0? Is it x squared minus 9/5? How do we know? So what we do is we say plus c. And it could be that c is 0 and we don't even have to worry about it, but you got to include it until they tell you more. So that's the antiderivative. When they start solving initial value problems, they actually give you some stuff that lets you, I know this curve that has the point 1, -2 on it. See, one thing I'm kind of skipped over here is that's the second derivative. So we're gonna have to find the antiderivative twice. So we've just done it once. So really what I've got right here is the first derivative. And then I'm going to say again, and then I got to solve it for, for C. So, and then I do the antiderivative again and solve it for the new one. And then I'll get that answer. So how did I do that? Well, I did it ahead of time, folks, just so that I didn't, I knew what my Alpha Math was looking for. And let me find my work here. Is it here? Oh, heck, let's see. Come on, give me that. There it is. Okay, so I said there's the second derivative. I did the antiderivative just like what I told you. I added 1 to 4, got 5. So then I divided by 5, and I could put it as x to the 5th over 5. I like to write it out front. It doesn't matter, whatever you want to do. I like to write it out front because it makes it easy when I take derivatives. And notice I went plus c. And then they told me that the first derivative, when the first derivative has about x value is 1, y equals -2. So I just took this information, replaced -2 for y and 1 for x, and I did this arithmetic. Now, we certainly could write this as -0.2.2. I don't think that'd be wrong. Tends to be that if you write as a fraction, it tends to get it's marked right. Okay. So that's what I did, is I rewrote -2 as -10 over 5, and then I subtracted 1/5. I got -11/5. So now here's my first derivative without any constants. That's that specific answer. So now they want me to find the actual function. So I got to go again. So I added 1 to there, got 6, and then I divided. I'm only going to do this. My high school students have a hard time with fractions still. So. So I have 1/30th divided by the 6. Well, isn't divided by 6 the same as multiplying? I'm sorry. Yeah. 1/5. Sorry, not 1/5. I'm ahead of myself. I have 1/5. I have this 1/5 divided by 6. So that became 1/5 times 1 over 6. We divide, right? 1 over 5 divided by 6 over 1 becomes 1/5 times 1 over 6. So that's where I got the 1/30 from. And then of course this is just a constant. This is x to the 0. So I added 1 divided by 1, same deal. And then plus a constant. And then I did the same thing with I did the same thing when y is 1, when x is 1, y is -2. It's interesting, they're the same values. That doesn't always happen. It's just what my open math did. So that's what I did. I said y equals -2 here. Let me clear all the extra stuff. I substituted y, -2 in for y, 1 in for x. Now, this is, fractions are my friends. Sometimes they're a pain in the butt, though. I certainly could have multiplied this by 6 over 6, made that -11 over 30. I mean, sorry, -66 over 30, and done some math there. What I chose to do, I noticed that 5 and 30 are, 5 goes into 30, right? 30 is a multiple of 5. So what I did is that's the lowest common multiple for 5 and 30. So I multiplied this by 30, this by 30, this by 30, and then this by 30. So what that did, I got rid of my fractions, made it pretty easy math now. So 30 times -2 is -60. 30 times 1 over 30 is 1. 30 times 11 over 5. Well, I know that 30 divided by 5 is 6. 6 times 11 is 66. Okay. Combined terms, added 65, divided by 30, made it 1/6. And there's my original function. Okay. And that's what my math liked. Okay. Just out of curiosity, did they have, they wrote it as over and they didn't give fractions. So I'd try it, see, get some help. Ask for some help if you need it. Okay.